In this video, we'll understand reinforcement learning from scratch. We'll see how an agent learns by trial and error, how rewards guide behavior, how RL differs from supervised and unsupervised learning, and the key building blocks like policy, reward, value, model, and environment. And yes, there will be quick quizzes in between, so you can check your understanding. Reinforcement learning, or RL, is a branch of machine learning where learning happens through interaction with an environment. Instead of being told the correct action directly, the learner tries actions, sees the result, and gradually improves. So in simple words, RL is goal-oriented learning driven by trial and error. The main idea in reinforcement learning is reward. Suppose a robot can move left or right. If it hits an object, we may give a negative reward. If it avoids the object, we may give a positive reward. Over time, the agent learns which actions are better because it wants to collect more reward. This reward signal is what shapes behavior. A positive reward encourages an action to be repeated, while a negative reward tells the agent that something went wrong. Bit by bit, through repeated experience, the agent becomes smarter in choosing what to do next. Now, let us look at this in a simple table format. Supervised vs unsupervised vs reinforcement. 3 learning styles in machine learning. Now let's compare reinforcement learning with the other main machine learning styles. In supervised learning, the model learns from labeled examples. In unsupervised learning, it looks for hidden patterns in data. In reinforcement learning, the agent learns from reward feedback and tries to maximize long-term reward. That is why RL is not the same as unsupervised learning. A very common confusion is that reinforcement learning is just another form of unsupervised learning. But that is not correct. In unsupervised learning, the aim is to find hidden structure. In RL, the aim is to act in a way that maximizes reward over time. The agent is not just analyzing data, it is making decisions and learning from consequences. Now that we've covered RL basics, let's test what we've learned so far. Here's quiz number 1. See if you can get it right. Question 1. How does reinforcement learning mainly learn? The correct answer is by trial and error. RL learns by interacting with the environment, trying actions, and improving based on outcomes. Question 2. What guides an RL agent toward better behavior? The correct answer is rewards and penalties. The agent receives feedback in the form of rewards or penalties, which helps it learn better actions. Question 3. What is the main goal of reinforcement learning? The correct answer is maximize reward. The core objective in RL is to maximize the total reward over time. In reinforcement learning, the agent is the learner or decision maker. It is usually a software program that interacts with the environment, takes actions, and receives rewards based on those actions. A simple example is a game-playing character like Super Mario learning how to move through a level. A policy tells the agent what to do in different situations. More formally, it maps states of the environment to actions. You can think of policy as the behavior rule of the agent. In RL notation, policy is often represented by the symbol pi. Reward and value are closely related, but not the same. A reward is the immediate feedback for a state or action. A value tells us how good a state is in the long run, considering future rewards as well. So reward is immediate desirability, while value is long-term desirability. A model is the agent's representation of the environment. In model-based learning, the agent uses previously learned information to plan better. In model-free learning, it depends mainly on trial and error experience. The office route example is a nice way to remember this. Using a known map is model-based, while testing routes one by one is model-free. Now that we've covered agent elements, let's test what we've learned so far. Here's quiz number 2. See if you can get it right. Question 1. In reinforcement learning, what is the agent? The correct answer is the decision-making learner. The agent is the learner, that takes actions and receives rewards from the environment. Question 2. What does a policy describe? The correct answer is a mapping from states to actions. A policy defines how the agent behaves in each state by choosing actions. Question 3. How is value different from reward? The correct answer is value reflects future reward. Reward is immediate feedback, while value estimates the long-term reward from a state. The environment is everything outside the agent. It is the world the agent acts in. When the agent takes an action, the environment responds with a new situation and usually a reward. So learning in RL always happens through this agent-environment loop. Environments can be deterministic or stochastic. In a deterministic environment, if you know the current state in action, you can predict the outcome exactly, like in chess moves. In a stochastic environment, there is uncertainty, like rolling a dice, where the exact outcome cannot be known in advance. Reinforcement learning has many practical applications. It is used in robotics, delivery and logistics management, and game-playing AI. More broadly, RL is useful wherever a system must make decisions, learn from feedback, and improve performance over time. Now that we've covered environment and uses, let's test what we've learned so far. Here's quiz number 3. See if you can get it right. Question 1. What is the environment in reinforcement learning? The correct answer is everything outside the agent. The environment includes the outside world the agent interacts with. Question 2. Which is an example of a deterministic environment from the lesson? The correct answer is chess moves. In the article, chess is used as an example where outcomes are predictable from the current state. Question 3. Which of these is mentioned as an application of reinforcement learning? The correct answer is delivery management. The article lists robotics, delivery management, and game-playing AI as applications. That was your beginner-friendly introduction to reinforcement learning. In the next steps of your learning journey, you can move into topics like Markov decision processes and Bellman equations. If you understood the quiz as well, you already have a solid foundation. See you in the next video.